Hello and welcome to Technical Insights. In today's video, we'll learn about different types of valves, how they work, what shape they have, and where they are used in real systems. Gate valve. A gate valve has a round body with a flat metal gate inside. On top, it usually has a round wheel handle. When you turn the handle, the gate moves up to open the flow or down to stop it. The inside pathway is straight, so when the valve is open, fluid passes easily with almost no resistance. Gate valves are used in steam systems, mostly for shut-off purposes and not for flow control. In oil pipelines, they are very common because they are strong and can handle high pressure. In gas systems, they also work well when a full open or full close is needed. However, in slurry systems, gate valves are not a good choice. The thick particles can get stuck under the gate and cause leakage or jamming. This type of valve is preferred when we want a full flow with minimum resistance and only need to open or close the flow, not control it. Globe valve. The globe valve has a round, globe-shaped body. Inside, there's a disc that moves up and down to open or close the flow path. The handle on top is usually a round wheel. The fluid inside moves in a curved path, which gives better flow control but creates more resistance due to its flow pattern. This valve is excellent for steam systems because it handles high temperature and pressure very well and can control flow easily. In oil systems, it's used when pressure regulation is needed. For gas, it works well but mostly in low to medium pressure applications. In slurry systems, it is not ideal because the flow path is not straight, and thick fluids can clog the valve or wear out the seat quickly. Globe valves are chosen when accurate flow or pressure control is needed, especially in high pressure or high temperature services like steam. Ball valve. The ball valve has a compact body and a round ball with a hole in the middle. On the top, it has a lever handle. When you turn the handle, the ball rotates. If the hole lines up with the pipe, the fluid flows freely. If the ball is turned sideways, the flow stops completely. It only takes a quarter turn to operate. Ball valves are widely used in gas systems because they give a tight seal and are quick to open or close. They are also common in oil pipelines because they handle high pressure and corrosive fluids easily. In steam systems, they are used for low-pressure steam, but not recommended for very high temperatures. In slurry systems, ball valves are not suitable because solid particles can damage the ball surface or get stuck inside. This valve is chosen when a quick shut-off and tight sealing is needed, especially in gas and oil services. Butterfly valve. The butterfly valve has a round flat body with a disc in the center. A lever or gear on top rotates the disc. When the disc is parallel to the flow, fluid passes. When turned 90 degrees, the disc blocks the flow. The design is very compact and lightweight. In water or slurry systems, butterfly valves are commonly used because they are easy to operate, even in large sizes. They are sometimes used in steam systems, but only for low-pressure applications. In oil and gas pipelines, they are not ideal for high-pressure use because they don't seal as tightly as ball or gate valves. This valve is often chosen for its light weight, quick operation, and cost-effectiveness, especially when space is limited or when handling large flows like in slurry or water systems. Check valve. A check valve looks like a short round pipe. Inside, it has a small flap, disc, or ball that moves when fluid flows in the right direction. If fluid tries to flow backward, the valve closes automatically. There's no handle because it works on its own. In steam systems, check valves are used to stop reverse flow, protecting boilers and piping. In oil and gas lines, they prevent pressure from flowing back, which could damage pumps or cause leaks. In slurry lines, check valves are used sometimes, but they need to be heavy-duty types because the solids can damage the internal parts. Check valves are used where backflow must be avoided and systems must stay pressurized in one direction only. It's used commonly at pumps discharge. Pressure relief valve. A pressure relief valve has a vertical body with a spring and a pop-up cap on top. It stays closed under normal pressure. When pressure gets too high, the spring compresses, and the valve opens to release excess pressure, then closes again automatically. This valve is critical in steam boilers, where pressure must never go above the safe limit. It's also used in gas cylinders and oil tanks to avoid explosion or system damage. It is not used directly in slurry lines but may protect systems that feed or drain slurry. This valve is a safety device used to protect people and equipment from overpressure in steam, gas, and oil systems. Its detailed video is available at my channel. Needle valve. The needle valve is small and has a thin, needle-like plunger inside. When you turn the small handle, the needle moves slowly into a tiny opening, which gives very fine control of flow. It is not commonly used for steam or slurry because it is made for small flow rates. In oil systems, it may be used for pressure test lines. In gas systems, especially in laboratory or small instrument setups, needle valves are very helpful to adjust flow precisely. Needle valves are best where very small and accurate control of flow is needed, especially in gas or testing systems. Plug valve. The plug valve has a short, round body and a tapered or cylindrical plug inside. Like a ball valve, it rotates to open or close the flow. The hole in the plug aligns with the pipe when open. Plug valves are used in oil and gas pipelines for quick shut-off. They can handle thick and dirty fluids too. In slurry systems, they perform better than ball valves but are still at risk if the particles are too large. For steam, they are used only in certain process systems. Plug valves are reliable in sticky or thick fluids, making them a good option for oil and certain chemical applications. Diaphragm valve. This valve has a flexible diaphragm that is pushed down to block flow. The body is shaped like a small chamber, and the diaphragm separates the upper part from the fluid. In steam systems, it is not commonly used because high temperature can damage the diaphragm. In oil or gas, it's used only for low-pressure applications. It works best in water, clean chemicals, or light slurries where hygiene is important, like in food or pharmaceutical lines. Diaphragm valves are used when the fluid must not touch moving parts or when cleanliness and corrosion resistance is important. Foot valve. The foot valve is a type of check valve installed at the bottom of a suction pipe. It has a built-in strainer to stop dirt from entering. It opens when the pump starts and closes when it stops, holding water inside the pipe. It's mainly used in water and slurry pump systems to keep the pump primed. It's not used in steam or gas. In some oil pump systems, special foot valves are used to avoid losing suction. Foot valves are important in pumping systems to stop loss of prime and protect the pump from dry running. Float valve. The float valve has a ball float attached to a lever. As the water level rises, the float goes up and pushes the valve closed. When water goes down, the valve opens to refill. Used in water tanks, cooling towers, and sometimes in oil tanks. Not used in steam, gas, or slurry systems. Float valves are simple and automatic, used for level control in storage tanks. Valves maintenance video uploaded soon. Comment anything you want to know or share. Thanks for watching.